The argument of a complex number z is the angle that the line joining the complex number to the origin makes with the positive side of the real axis. So here we have the complex number z. Here's the blue line joining z to the origin. If we got the distance of this blue line, we would be getting the modulus of z, because the modulus is the distance from the complex number to the origin. But we're not interested in the modulus in this particular question. We're interested in the argument. And the argument is the angle that this line makes with the positive side of the real axis. So the real axis is what we are used to calling the x-axis. It's the horizontal line. And the imaginary axis we are used to calling the y-axis. We call it x and y for coordinate geometry. We call it real and imaginary for complex numbers. So this is the real axis, and everything to the right of the imaginary axis is the positive part, and everything to the left is the negative part. So the angle that this line makes with the positive part of the real axis, so basically this angle here, this is known as the argument of z. So you have to go in an anti-clockwise direction. So for example, if z, our complex number, lies on the negative part of the real axis, let's say it was here, then the angle would be 180 degrees, because this would be a straight line. If it was somewhere here on the positive part of the imaginary axis, then the angle would be 90 degrees. This is a 90-degree angle, and so on. z1 equals 1 plus I, and z2 equals minus 1 plus I. Part 1. Evaluate z3 if z3 equals z1 multiplied by z2. Remember, anything stuck together in maths means multiply. Part 2. Plot z1 and z2 on the Argand diagram. Using a protractor, find the angles that z1 and z2 make with the positive side of the real axis, i.e. the argument of z1 and the argument of z2. Part 3. Plot z3 that you worked out in part 1 on an Argand diagram. Part 4. What is the argument of z3? Part 5. How is the argument of z3 related to the argument of z1 and the argument of z2? Okay, so we're going to work out part 1. We want to evaluate z3 if z3 is z1 multiplied by z2. Remember, z1 and z2 are stuck together, so we multiply. Anything stuck together in maths means multiply. So we replace z1 with 1 plus I and put brackets around it. And we stick on to that, we replace z2 with minus 1 plus I with brackets around it. So we have 2 eggs. We're going to crack open the first egg. We bring the 1 down here and stick on the second egg. Then we bring the plus I down here and again stick on the second egg. Now we multiply out the brackets. 1 multiplied by minus 1 is minus 1. And 1 multiplied by I is plus I, or you could say plus 1I, which is the same thing. I multiplied by minus 1 is minus I, or minus 1I. And I multiplied by I is I squared. We bring down the minus 1. Plus I minus I will cancel, and the I squared becomes minus 1 with brackets around it. And minus 1 plus minus 1 is minus 2. So z3 is minus 2 plus 0i. So the real part is minus 2, and since we had no part with an I left in it, we just say we have 0i. Part 2. Plot z1 and z2 on an Argand diagram. So an Argand diagram is like a x and y axis in coordinate geometry, except instead of an x-axis we have a real axis, and instead of a y-axis we have an imaginary axis. So z1 is 1 plus 1i. So we go across to 1 on the real axis and up to 1i on the imaginary axis. And we plot the point z1. z2 is minus 1 plus I. So we go to minus 1 on the real axis. We go to plus 1i on the imaginary axis. And then we plot the point as z2. Using a protractor, find the angles that Z1 and Z2 make with the positive side of the real axis, i.e. the argument of Z1 and the argument of Z2. So if you place your protractor down along the real axis, so your baseline should line up with the real axis, and the center of your protractor should be at the origin, you should see that the angle formed from Z1 to the positive part of the real axis is 45 degrees. So it's an acute angle which is less than 90 degrees, so it's 45 degrees. And the angle formed with Z2 and the real part, the positive part of the real axis, we can see is an obtuse angle, which means it's more than 90 degrees but less than 180 degrees, and it should measure to be 135 degrees. Part 3. Plot Z3 on an Argand diagram. Well, we worked out Z3 to be minus 2 plus 0i. So we go to minus 2 on the real axis and 0 on the imaginary axis, which is obviously in the origin. So we plot the point minus 2 plus 0i. So this is Z3, and it's actually on the real axis. Part 4. What is the argument of Z3? So basically, what angle is formed with the real axis, the positive part of the real axis, and the complex number Z3, which is here. And remember, we start at the real axis, the positive part of the real axis, and we have to go anti-clockwise, and we get 180 degrees because this is a straight line, which is 180 degrees. So the argument of Z3 is 180 degrees, which is a straight angle or a straight line. Part 5. How is the argument of Z3 and related to the argument of Z1 and the argument of Z2? Well, the argument of Z1 was 135 degrees. The argument of Z2 is 45 degrees. And adding these together, you get 180 degrees, which is equal to the argument of Z3. So if Z1 and Z2 are complex numbers, then the argument of Z1 plus the argument of Z2 is equal to the argument of Z1 multiplied by Z2.